Hi, today we are going to talk about superposition. This is the principle which we use while we are dealing with the charges. Now, what does superposition means? In simple words, it is addition, nothing else, addition. But how we do this addition, that matters. So if you see, superposition means addition, and in our cases, we'll be adding forces. Forces. So how we add forces? Because they are a vector quantity. Remember that forces are a vector quantities. So what we finally do is we do vector addition. Now let's see what is the need, which forces we are going to add. We already do this superposition, but in our mind. Let's say, for example, I have a charge here, this charge, and let's say its value is Q. And now I'm placing one more charge here, which has the same magnitude, Q. So what will happen? They are both positive charges. They are both positive charges. They will repel. So if I ask you what will happen with this charge, you will say, okay, it will experience a force onto this side, so it will go this side. So that we know. But what if now I place another charge here also? Its magnitude is also Q, it is also positive. Now again, there's some question, what will happen to this charge? This will move or not? So to move or not? Tell me. So you give it some time. What is your answer? Correct. So in our common sense, we can say that this charge will not move because we can say it is having forces from both sides. Let us visualize that force. So this charge will repel this charge to this side. So I can show by this vector, and there will be some force. And this charge will also repel this charge to this side. And because the distances are same, the charge values are same, this will be also equal. So if we add them or superposition them, then we will get that net force will be equal to 0. So what we have done in our mind when we were saying that this charge will center mass will not move, what we are doing, we are actually doing vector addition in our mind. We are superpositioning forces on this charge and then finding it whether it will move or not, because it will experience both sides same force. It is not going to. Okay, and the reason is because there is no net force. So again, we have a charge Q here, positive charge Q, and here I have minus Q charge. Okay, minus Q charge, this negative charge minus Q. Again, I'll place here also one charge. That is also minus Q. So can you tell me now, will it move? This will move or not? Think about it. Again, in your mind, you have done vector addition or you have superpositioned each forces on this. So due to this, it will attract this side. Due to this, it will attract this side. And this will be equal forces because see the magnitudes are same. Magnitude of charge is the same and distance between them is also same. So they will again cancel out and we will say net force will be equal to 0. So we are doing the cases where the charges, multiple charges on the same line. And if somebody asks like what is the net force on any charge, what we are doing is we are applying forces on that charge, calculating it, and then with our common sense, finding it whether it will move or not, if there is a net force or not. In this case, there is no net force. Now let us take some example where there is some net force. Now let us take some values also. So I'm taking this as x-axis, and this is 0, this is 1, this is 2, this is 3, and these distances are in meters. And now let me place charges. So there is one charge here, positive. It's a positive charge, and its value is say 2 coulomb. There is another charge which is placed on 3, position 3. It is also a positive charge. Its value is 2 coulomb. But there is another charge at 0. It is positive charge. Its value is 2 coulomb. In this case, what will happen to this charge? Will it move? If it will move, in which direction it will? So yes, it will move because now it is not the same case. This is very closer and this is very far away. So the net force will be on this left side. So if you don't believe it, we can use superposition principle in action and calculate the forces. So that I don't get confused which charge is which. So I'm just naming them. So I'm just naming this charge as Q0 because it is situated at 0. This charge I'll say about refer it as Q2. and this charge I will say Q3. Okay, so now let us apply superposition principle or let us add forces. The question asked is what is the net force this charge is experiencing? Okay, net force on Q2. So let us calculate one by one what are the different forces acting on it. So this charge is experiencing a force by this charge, right? And we can write that will be the force on Q2. I'm writing as 2 due to the charge which is at 0. So F20 I can say. So we can calculate it by Coulomb's law. Another force it is experiencing is force on 2 due to the charge which is placed at 3. So these notations will really help you when there are multiple charges to understand which force we are talking about. So now we just need to apply the formula. Okay, so first let's calculate this. They have Coulomb's constant Q1 divided by Q2. So both charges we need to multiply. So it will be 2 multiplied by 2 divided by what is the distance between them? See, the distance is 1, 2 meters square. So this we need to solve. And for F23, it will be 9 multiplied by 10 raised to power 9 multiplied by what is the charge's magnitude? It is only 2 by 2. But the distance between them is now only 1. So it will be 1 square. So if we calculate the magnitude, if you calculate this, you will get F20 is equal to 9 into 10 raised to power 9 Newton. And you will get F23 equal to 3.6 into 10 raised to power 10. So which one is more? F23 is. How to read this? How to read this? It is force on 2 due to 3. Why it is more? Because it is nearer to each other. So how to draw diagrams now? So they'll be, let us superposition it. So we'll position what is the force due to this charge like that, because it will be the same line joining the charges. And we'll call this is what we are calling F23, which value we have calculated this. And what will be the F20 due to this also repelling force, but it will be smaller than this. Okay, so I'm just keep this arrow smaller than that, and I will say this will be the force on 2 due to 0. So we can clearly say what will be the net force here. So for the net force, we have a diagram. We can do vector addition. They are in the same line, so we can do addition and subtraction. So we will simply say it will be F23 minus F20, and that will be the force. So it will be 36 into 10 raised to power 9 minus 9 into 10 raised to power 9. I can take 10 common. So only 36 point minus 9 will be inside, and I have taken 10 raised to power 9 common. So it will be 27 into 10 raised to power 9. If I want to write it scientific notation, I will say 2.7 into 10 raised to power 10. And now what will be the direction? See, which force is more? F23 is more. So the net effect, net force, I'm just showing by red. I should show net force here, but I'm just showing above here, so that diagram looks neat. So the net force will be in this direction. This is the net force, which is of 2.7 into 10 raised to power 10. The way to understand this is this will repel more, this will repel less, and the net force will be in this side, which will have this magnitude. And how we calculated it? We just saw from the diagram which force is more, which force is less, and then we say, oh, it will go to the left side because left side force is more. This part will be just cancelled out. So this is what we have done here. We reduced that force and we got the answer like this. Now let us try with this question. Here I've drawn x-axis and I've taken 0, 1, 2, 3, 4, 5 different numbers on this axis, and different charges are placed. Remember, at 1 the charge is negative minus 4 coulomb, at 3 the charge is 2 coulomb, and at 5 the charge is 4. Now what is asked is what is the net force here on this charge? Net force we are asked. Remember that they can ask at any point, like the question can be also what is the net force will be here. The question can be what is the net force here. So we should be ready with that, and that is why we are doing simple notations when noting down the forces. So this will really help you. Like for example, let us name them first. So I will call this charge as Q1. This charge I will call Q3, and this charge I will call Q5. Because knowing this, I will get to know where this charge is. I will not get confused. So I want to calculate net force here. So I will say the force on Q5, I just will write 5 due to 3, F53 will be equal to what? Okay, so I will apply 9 into 10 raised to power 9. What are the charges at 5 and 3? 5 and 3 is just 4 into 2. 4 into 2. divided by distance between them is 2. 3 to 5, the distance will be the 1 and 2. So it will be 2 meters. So I will square it like that. And this will get cancelled out and we'll get like 18 into 10 to the power 9 Newton. So we got one set of force on this charge. Let us calculate the other one. What will be the force on 5 Q5 due to 1? So I will write it like that. I have 5 1. So there is no confusion which force I am talking about. It will be 9 into 10 to the power 9. What are the charges at 5 and 1? They are 4 and 4. Remember that when we are calculating forces magnitude, we don't put sign of the charges. So I will not write -4 here. And what is the distance? I need to count. It is 1, 2, 3, 4. The distance between them is 4. I have to square it. 4 square. So it will become easy because above also numerator there is 4 into 4. So this will get cancelled out. I will just simply get 9 into 10 to the power 9 Newton. Now to calculate the net force, we need forces superposition here. So let us superposition the forces. These charge will repel. So F53 will be in this side towards the right side. They will repel. This charge will repel this charge. So I will draw an arrow like this. This is F5. After calculation, we should know which direction it will do, and that is a common sense positive charge repel. So this is the F53 we have calculated. Now see the second force, which direction it will be? That is negative charge, and this is a positive charge. So it will be attractive force. I'm using a different color to show that, and it will be because they are far apart. We have calculated the value have come very less. Then in comparison, it is just exactly half of it. I will write it like half of this will be somewhat less. So just draw like that. Okay. So now I can say this is the force on 5 due to 1. Now we can seeing this diagram, we can clearly say the net force will be in the direction which side will be on the right side. Can we calculate it? Yes, we have superpositioned them. We just need to calculate now net force. Net force will be F53 because that is more. This side force is more minus. We have to reduce this force F1 and that will be 18 into 10 to the power 9 minus 9 into 10 to the power 9. 10 raised to the power 9 you can take common and it will be 18 minus 9 into 10 to the power 9 and then it will become 9 into 10 to the power 9 Newton. So this is the net force on this charge due to this and this. So this is the net effect. So we can take it by common sense also when they are in line, but also with draw forces, automatically we'll get to know where it will go. Why we can just, when I drew this, I got to know that will go to the right side because this is more, this will reduce the effect. It will get subtracted. It will get subtracted and we'll get the net force. If you want me to draw the force, the net force, I can draw on the right side. It will be like this. Like this, I can show. And this is the net force which we have calculated as 9 into 10 raised to 1. This is our net force.